There at University of Queensland is Matt Watts, and he's directed by Hugh Possingham. And as Bruce mentioned, Marxan is one of the most widely used marine conservation tools, and all Marxan with zones is just a sister application of that, I guess, with some additional features that I'll get into. And the main objective of either for Marxan or Marxan with zones is that what you're trying to do is minimize socioeconomic cost, subject to that you meet your targets. And we often think of targets, or we consider targets, as biodiversity targets. And it's done in such a way that you set what those targets are, and it will always achieve those targets. But there's different ways of parameterizing it so that you can minimize your costs. So all Marxan with zones is it's a new tool that allows for multiple zones. They're the consideration of multiple zones, multiple costs, and zone-specific constraints. And I'll get into what each of those mean in the next couple of slides. So just kind of as a setup, I kind of mentioned it on that previous slide, but the basic theory here is minimize cost of selected sites, your reserve system, and how EcoTrust has considered cost, and I don't know that this is widely used or not. I think some people use other things for cost, but based on the process that we're working in California, based on the data that we collect in California and the outcomes that we're trying to achieve, we consider our fisheries data as our cost layer. So we go out and we collect data on commercial fishery activities in the ocean and the value of those activities, and we use those as the cost. So we're trying to minimize the impact to those fisheries. And then we're on the other side of things, we're trying to do that subject that we meet all of our targets, or that's the constraint. And so in the example I'll give, we'll go through and we set our targets based on data or based on the science criteria that was developed in the MLPA process, and then the data that supports that criteria. This may be somewhat repetitive for some of you folks that are familiar with Marxan and have used it. But this kind of gives you a sense for targets. So when I talk about targets or habitat features, this example here are the targets that were identified by the science body in the California process. And again, it's specific to that. It's not like these targets translate everywhere, but these are the types of habitats that they wanted represented in their network system. And those targets for Marxan or for Marxan with zone are represented by percentages. So either percentage based on linear distance within a planning unit or area within a planning unit. And this example here was based on not the paper I'm going to present here, but a previous paper where those because percentage, how much percentage you set as a target can be a very controversial topic. Like, no one wants to say like 30% that's what you need, or 50% or 10%. There's different papers out there that specify why you set targets at certain things. But in this example, what we did is we left that issue up to the stakeholders, because it's a stakeholder-driven process in California. And what we did is through each time they were drawing MPAs, we just took the MPA network that they created and just intersected it with all the habitat data that we had to run a Marxan, and we just used those percentages and then compared those networks to the networks that were being outputted from Marxan. So a little bit more just what we mean by habitats and planning units and the amounts. So how we've handled it is you have a feature here, submarine canyons. This is Morro Bay. Moss Landing there is would be on the right hand side, and we set our planning units, and there's a whole process for going through and determining the appropriate size planning unit, usually based on your input data. And then we just go through and summarize the amount of that feature into each of those planning units. And in this case, they wanted that habitat feature. Anything that was usually bottom substrate type, they wanted summarized across or broken out by depth zone. So we have slope, shelf, and near shore. So for each of those, on the previous slide, those 32 features, we go through an GIS exercise of summarizing that information to the planning units. And then we can set those percentages and run the Marxan exercise scenario. So now I'm going to kind of transition into talking a little bit about the differences between Marxan and Marxan with zones. Again, I'm giving context based on the process that we used it in, which was California's Marine Life Protection Act process. So in that process, they basically went through and identified different types of marine protected areas, and those protected areas basically allow different types of fisheries or activities extractive activities to occur inside those areas. And so you have everything from a marine reserve, which doesn't allow anything, to parks that allow some recreational fishing activity, to conservation areas that allow differing levels of commercial and recreational activity. And so if you were just to use something like Marxan, you basically can't really address the real world scenario of you have this gray area in between reserved and available. We needed to be able to address those areas that are supposed to be parks or conservation areas. So what Marxan with zones does allows you to define what those zones are, and then attribute the different types of costs to each one of those zones. So if you have a fishery that's allowed in a conservation area, and Marxan with zones selects that site, and that fishery is allowed in that zone, then it's not going to be a cost to be able to put that MPA in that zone. So trying to get at the idea of flexibility with this zoning feature. Now, in terms of targets or conservation features, you can also now set targets per zone type. So you still have to, the important thing here is that you have to be able to define your zones, and not only ecologically, like what you want your zone to do, but also, on the economic side of things, what you want to allow in there, and those things should jive. But this example here is that instead of just being able to cite everything into one type of zone, let's say you wanted at least 10%, and that's what we wanted to do in the example I'll show later. So we wanted at least 10% of all of our features in a reserve, and then the remaining 20% could go anywhere. And so it gives you that flexibility of being able to set zone-specific targets. So you have zone-specific targets, and then you have zone-specific costs. And so, when we did this exercise the first time using just Marxan, basically we had 20 different fisheries, and you basically have to take all of those fisheries for each planning unit and basically come up with a total value of fishery, I guess, for that planning unit. And Marxan just considers either or, right? It just says either it's reserved or it's open, and it's 100% cost to all the 20 fisheries, or no cost at all. What Marxan with zones does is, at least in the example in California, there are certain fisheries that are allowed in conservation areas. So when it cites an area into that zone, it basically goes through this list here. So you see the SMCA on the right-hand side, and it goes through, and if there's an anchovy fishery there, then it says, well, it's not going to be a cost to that fishery because that fishery can occur in that zone. So it goes through all 20 of your cost layers, your fishery layers, and you could have as many. And basically the idea is that it does it on a per fishery basis or a per cost basis. Okay, so that was kind of the setup of the new kind of features or flexibility of Marxan with zones. And then I'm going to talk now about how we applied it to a specific region in California. And what the objective there was to evaluate trade-offs between representing biodiversity features compared to impacting fisheries. And really what we did there is, and I'll get into it, is I guess the more I think about it, was kind of going through an exercise of kind of stating the obvious of comparing Marxan versus Marxan with zones, and that you're going to achieve better outcomes, at least on the economic side of things, with Marxan with zones because you have more flexibility. All the same, I think it was a worthwhile exercise. So the Marine Life Protection Act, basically what it is, if you're not familiar, in California, it's a law that mandates the state of California and gives them the authority to redesign a network of protected areas, MPAs, with inside state waters. That act was passed in, I believe, 1999, and it took them a couple of tries to get to the point where they're actually implementing the planning process. The example I'm giving you there, so they broke up California into 5 regions and have